Good day, grade 7s, 8s and 9s. Today in mathematics we are looking at congruent triangles. Now I know some of you grade 7s are touching on the subject. The grade 8s and 9s, you definitely are doing this. So just up to where you are going, just stop there. I am going to go further up to where the grade 9s normally end. So just take that into consideration when you're watching this presentation. Okay, so when we are looking at congruency, it actually means that it is when two shapes are exactly the same in size and in shape. Then they are called congruent shapes. So for example, if I have a pentagon and I just turn it and move it and place it in a different direction, those two are still the same thing. So I took it, I copied it, I turned it around, I can flip it, I can move it, but it is exactly the same shape and size. Another example, if I take this rhombus and I turn it, change it, it still remains exactly the same. Next one, this triangle, move it to a different direction, turn it, rotate it, it still remains the same thing. I haven't changed anything about it, I've just changed its position. So if I cut it out and I put them on exactly on top of each other, then you will see that it is exactly the same thing. So if two triangles are congruent, then each side will be the same size as the corresponding side of another triangle, and each angle will have an equal corresponding angle in the other triangle. So while that is a complete mouthful, so instead of doing that, let's divide this statement into two parts. So the first part reads, if you have two triangles that are congruent, then each side will be the same size as a corresponding side of another triangle. So what does this part mean? This part means that if I've got two triangles and it's stated that they are congruent, then for this side I will have exactly the same side in the other triangle, and another two sides will be exactly the same, and the third side will also be exactly the same. So that is analyzing the first part of the definition. The second part says each angle will have an equal corresponding angle in the other triangle. That means that if I look at the first triangle and I have one angle, I will have exactly the same size angle in the second triangle. And the same applies to the other two angles. So that means that this triangle has the same sides and the same angles than the second triangle. Next, we're looking at how do I write this out. So this is very important to know how you write it, because if you write it incorrectly, then the meaning obviously changes. So first of all, the order in which the letters of the angles are written are crucially important. For example, if I have a triangle MNO and I tell you that it is congruent to triangle ABC, then angle M will be the same as angle A. Angle N will be the same as angle B, and angle O will be the same as angle C. However, if I change the order of the letters, for example, I change these three angles, now the angles are different. So M will now be equal to C, where N is equal to A and O is equal to B. So my triangles are actually different triangles. This triangle is not the same as this triangle. They are actually two different triangles. And I can do the same thing again and shuffle the angle letters, and then I'll have a third triangle which does not, well, it looks the same, but it isn't the same as those two. So just be careful that you write the corresponding angles that are equal to each other in this correct order so that you don't mess them up. Okay. Next, we are going to look at the properties of congruent triangles. So if they tell you that the two triangles are congruent, what does it mean? It means that the corresponding angles are equal. Therefore, if I have two triangles and I call the one M and O, and ABC, how am I going to write down the properties that we know now? So the first property obviously reads that the corresponding angles are equal. So now the statement that they give you will look something like this. In the triangle MNO, that is this one, MNO, it is congruent to triangle ABC. Now the letter order matters because this is where you get your information from. So this information tells you that this angle M is the same size as angle A. Angle M will therefore be the same as angle A. Next, we're looking at yellow, angle A and B. Okay, let's just write it out. So how do we write this M and A equal to each other? We write angle M equal to angle A. So this is the one method of writing it. The second format looks like this, where angle NMO is equal to angle ABC, where the angle that you're working with falls in the middle. So that one refers to NMO, so that's your first angle. You can also write OMN as long as M is in the middle. On this side, you have angle BAC or CAB, which means those two are equal. The next angle that we're looking at is the yellow one. N and B is equal. Therefore, in this triangle, N is the same size as angle B. Okay, so again, how do we write it? We write out angle N is equal to angle B, or we can say angle MNO is equal to angle ABC, where the angle that I'm referring to is in the middle. Next, we have angle O. Angle O equal to angle C, that is our last red angle here. So those two are the same size because they are given to us, and it is also the third angle. So we write it as angle O equal to angle C, or MON equals ACB. So the order that you write these last two in doesn't matter. It could be NOM as long as the angle that you're working with is in the middle. Okay, the next property, okay, so that is the property that is crucially important, okay. Next, you are going to look at the conditions for congruency. So what conditions do I need to fulfill to make these triangles congruent? Okay, so the conditions is, if I look at the triangle, what in this triangle is the same as in that triangle, and then if I fulfill certain conditions, then I can assume that the triangles are congruent. So the first one is obviously you need to prove this, and you need to use valid proof to make the statements true. So the first proof is SSS, side, side, sides. All corresponding sides are equal. So if I have two triangles and this angle, this side is the same size, and that one are the same size, and this third one are the same size, then we can assume that the angles will also be the same, and therefore we can say that they are congruent. You can't have two triangles with the same size sides that are not congruent, because the angles will automatically be congruent. Okay, so these two are exactly the same triangle. Sometimes they are flipped around, so this one will be green and that one will be red. But as long as you have a side here and a side there, a red and a red, a green and a green, a yellow and a yellow, they will be congruent. The second condition is side, angle, side. So you will have to prove two sides are equal, two angles are equal, and another side are equal. So two corresponding sides and the angle between the two sides are equal. So it will look like this. Two triangles, I have the first one says side, there I have a side. Then I need an angle, there I have an angle. Then I have another side. So just remember, when we say side, angle, side, it literally is in the order that you can't say side here, that angle, and this side. No, it has to be the angle that falls next to or in between the two sides. Okay, so we have side, angle, side. The next condition is angle side, where two corresponding angles and any corresponding side are equal. So in this case, this order can change. You can have angle side angle, angle angle side, or side angle angle. The order here doesn't really matter because at the end of the day it would look something like this. So the first one is angle. So here I have an angle, then I have another angle that are equal, and I have a side that is equal. Okay. So there is our third condition for congruency. The next condition is a little bit more difficult. It says both triangles have a 90-degree angle and have equal hypotenuses and one other side is equal. That means that I have to have two right-angled triangles. If they are not right-angled triangle, condition number 4 is completely out of the question. Next is the hypotenuse. So where is the hypotenuse? The hypotenuse is obviously the side opposite the right angle. So the longest side. They have to be equal to each other. So now we've fulfilled two of these conditions. Our third condition is one other side is equal. So it can be this one or that one. Doesn't matter. But as long as I've got these three conditions, then my triangles are congruent. Okay, so you need to always prove three things. You need three statements and three reasons before you can prove it is congruent. Those three reasons have to be one of these. It has to be condition number 1, 2, 3, or 4. So angle, angle, side, 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 right angles, right angle triangles, hypotenuse and another side, or a side angle side. Those are your 4 conditions that you can try and fulfill. And then what will our proof look like? Now this part is important because how I write it out, how I set out my answer will determine how I get my marks. If it is all complicated and scribbled and no order, then we can't give you the marks that you deserve. The proof is a format that you need to use. It is a set format that a proof looks like in mathematics. So the format remains the same in grade 7, 8, 9, 10, 11 and 12. And as soon as you start practicing it in, the easier it's going to get. The setup looks pretty much the same for similarity and congruency. But all your other proofs you can kind of like go along the same format. Sometimes you need more than one set of statements, but for congruency and similarity you need 3 statements. So first we always start with what you need to prove. So I've got 2 triangles. So they won't always look like 2 separate triangles. They can be in one sketch, but at the end of the day I'm looking at 2 triangles. So I need to start with what I need to prove. What is in the question? So in my question, they are asking me to take this triangle and prove it congruent to that triangle. So I look at where I'm going to start. I'm starting in triangle PQR and I'm using triangle XYZ. Well, what about these 2 triangles? So the important part is you have to write this statement in the order that they need your answer to be. So look at the question and then you write down this. You can't go write down PQR and then ZXY because then you are proving the wrong angles equal to each other. So then after that you have to give 3 statements with supporting reasons. Now your supporting reasons can be anything that you have covered so far. You can use the properties of the triangles. 3 scalene, acute and obtuse triangles. You can use the properties of exterior angles of a triangle. You can use the property of interior angles of a triangle. You can use FunX. If you don't know what FunX is, please refer to my video on the types of angles. Okay, so any of those reasons that you have done so far that is fact, you can use to prove this. So then you're going to start with your first one. Angle PQR equal to YXZ. So this, I'm looking here at angle P and I'm looking at angle X. I wrote them out like this. You could have just said angle P and angle X, depending on what your sketch looks like. So I want to say that P is equal to X and I need to tell you why. Why are they equal? So your reason here could be any one of those that I've mentioned: exterior angles, interior angles, front X, whatever. And you write them out. So now the first thing I've proved is I've proven an angle. The next one I'm going to prove is angle Q. So angle Q, blue, compared to blue. X, Y, Z, and PQR. So Q equal to Y. And then again, any reason that you can think of that is proven in this sketch, or that you can use the sketch for. And in this case, I've proven another angle. Lastly, I'm going to prove that PQ is equal to XY. So remember, this is just a setup. It is not an actual example of how to do it. It is just the format of how you're going to do it. So in this example, I'm telling you that I'm proving a side. Again, that is going to be something that is given to you, something that you can work out, calculate. You can maybe use Pythagoras for this. All of those things that you've known about, you can use. So maybe you are using ratios, maybe you are using Pythagoras. Doesn't matter, but yeah, you again are going to have a mathematical reasoning. Okay, and then I'm going to say that it is a side. So I've proven an angle, proven another angle, and I've proven a side. So my conclusion therefore is I've done my 3 statements. I can now conclude. Therefore, triangle PQR in the order that I've proven it: angle P, angle Q, and the next side. Okay, again, as they set it out in the question. It's congruent. These 3 horizontal lines are referred to congruency. So PQR is congruent to triangle XYZ. And why is it? Because I'm using an angle, another angle, and a side. This is now my reason. Okay, and that, guys, is congruency for you. Please go and practice this. It's going to get easier the more you do it. There are a lot of textbooks out there to do this. I'm sure you can find some online as well. Yeah, good luck. Comment on the video, like it if you can, and give some feedback. Good luck.